Here we're going to learn about our inverse trig values. The inverse trig values are different than what we've learned before, which is the reciprocal. So when we're talking about an arc sine, or later on it has the same notation, this could be rewritten as sine to the negative 1, 1/2. Two different types of notation, they both mean inverses. Now when we're talking about inverses, there's a few things we need to know. First of all, for y equals sine x to have an inverse, it has to be 1 to 1, which means basically it has to pass the horizontal line test. So when we look at our sine graph, we know it looks like this, and it goes on and on forever and ever. And the whole graph itself does not pass the horizontal line test. So what we do when we work with inverses is we only look at a chunk of the sine graph. And for sine, we go from negative pi over 2 to positive pi over 2. We do this because in between these 2 points, we have an interval that's only increasing. It spans the entire range of what sine goes to. And just this chunk does pass the horizontal line test. So whenever we're talking about inverse sine, we're only referring to this little piece of the sine graph that we're taking the inverse of. Which means, on the unit circle, negative pi over 2 to positive pi over 2 encompasses quadrant 1 and quadrant 4. So anytime you're taking the inverse, your answer has to land in quadrant 1 or quadrant 4. Very similarly with cosine x. We know it looks like sine, it's just shifted. And in order to take inverses, we look at the chunk from 0 to pi. It's always decreasing, it spans the entire range, and it passes the horizontal line test. Unit circle, 0 to pi. Now I'm in quadrant 1 and 2. So inverse cosines have to be in quadrant 1 or quadrant 2. And last, if we talk about tangent graph looks like this over and over again. The chunk we look at goes from negative pi over 2 to positive pi over 2, just like sine. So you want to make sure your inverse tangents are in quadrant 1 and quadrant 4. So when I'm finding inverse values, I'm essentially answering a different question. Arc sine of 1/2 is asking, sine of what angle gives me 1/2? So you have to think, what quadrant am I going to be in? For sine, you have the choice of 1 or 4. So from 1/2, I'm definitely going to be in quadrant 1. Sine refers to the opposite, so I can label my opposite side 1/2. Now I know my adjacent side is going to be radical 3 over 2. What angle am I at if I'm across from 1/2? Well, I've got to be at 30 degrees. Or you could have said pi over 6. Okay, arc sine of 1. Sine of what angle equals 1? Well, 1 is going to land on one of your axes. Sine is our y distance. So where am I 1 away? Well, it's got to be up here at 90 degrees or pi over 2. Arc tan 1. Tangent of what angle gives me 1? So tangent, I hit 1. If you look over here at the graph, I actually hit 1 in the middle of the center and my asymptote, which lands me at pi over 4, which is the same as 45 degrees. When you are figuring these out, you can either refer to the graphs or refer to the unit circle, whichever is most helpful to you. Arctangent radical 3 over 3. So tangent of what angle gives me radical 3 over 3? First of all, what quadrant are you going to land in? If I'm positive, I'm landing in quadrant 1. My only choices were 1 and 4. So I'm landing in quadrant 1. Now, to get my opposite over adjacent, we know we're talking about common angles. So really, as long as I know this is not a 45, 45, 90, I've got two choices for this opposite side. It could be 1/2. It could be radical 3 over 2. Same with the adjacent side. So let's just pick one. Let's say the opposite side is radical 3 over 2, which means my adjacent side is 1/2. That means when I'm doing tangent, I've got to do my opposite side over my adjacent, multiply by my reciprocal, 2's cancel, I get radical 3. Well, that is not exactly what I wanted over here. So my other choice is to say, well, the opposite must be 1/2, and the adjacent must be radical 3 over 2. And what angle would I have to be at to make that happen? Well, across from 1/2's my shorter side, so that's got to be 30 degrees, or pi over 6. Number 5, you see we use the other notation, but it's asking the same question. Cosine of what angle gives me negative radical 2 over 2. Now cosine could have been in quadrant 1, or it could have been in quadrant 2. Since it's negative, we know it's in quadrant 2. Since it's cosine, I know the adjacent side was negative radical 2 over 2, which means I've got to be in a pi over 4 reference angle. And the opposite side is radical 2 over 2 if that's necessary. So I'm at pi over 4, but if I just say my answer is pi over 4, that puts it in quadrant 1. I want to give the bigger angle that leads it into quadrant 2, which would be 3 pi over 4, or 135 degrees. One more of these. Sine of what angle gives us radical 3 over 2? It's positive, so I'm in quadrant 1. Sine refers to the opposite side, so this must be 1/2. This angle right here has to be 60 degrees, or pi over 3. When we talk about trig graphs, or the inverse of trig graphs, we want to consider the original graph first. So sine, let's see, if I think of this as a unit circle, and you could think of it as a unit circle or a graph, it doesn't matter. Negative pi over 2, that's going to be negative 1. Negative pi over 4, now that's negative radical 2 over 2. Negative pi over 6, now my opposite side is negative 1/2. 0, I'm at 0. Pi over 6, positive 1/2, positive radical 2 over 2, and positive 1 as I work my way up. When you're finding the inverse table of values, you simply switch your x and y. But since I don't know where to put negative radical 2 over 2 on a graph, I'm going to change it into a decimal. So it's roughly negative 0.7. Negative 0.5, 0, 0.5, 0.7, and 1. So now I look at my graph. I've got to span my x-axis from negative 1 to 1. So I'm going to count by fifths. So this right here would be negative 1. 1, 2, 3, 4, 5. This is going to be 1. My my y-axis needs to go from negative half pi to positive half pi. I'm going to count by twelfths, pi over 12s, which means this would be pi over 6, pi over 4, pi over 3, and pi over 2. Same going the other way. Okay, and then I plot my points. At negative 1, I've got to be at negative pi over 2. So there's 1 point. At negative 0.7, remember these were counting by 2, so this is 2, 4, 6, 8, so I'm in the middle here. Negative 0.7, negative pi over 4. Negative 0.5 at negative pi over 6. 0. 0.5 pi over 6, 0.7 pi over 4, and 1 pi over 2. So if I connect these, you can kind of see that one little chunk of that sine graph we were talking about for inverses is now rotated. If this were to continue, it would be winding up and down the y-axis instead of before it was winding on the x-axis. We can't continue it, one, because we had to take a chunk in the beginning to make an inverse possible. Two, if I kept going, now this is no longer a function, it's failing the vertical line test. So when we're talking about inverses, we are talking about small chunks of the graph rotated. Okay, a cosine graph. I'm going to think about my unit circle. At 0, cosine is my x distance, so that's going to be 1. At pi over 6, that's the longer distance, so that's radical 3 over 2. Pi over 4 would be radical 2 over 2. Pi over 2, I've got to be at 0. 2 pi over 3, now this is going to be my short distance, so 1/2. 5 pi over 6 is my longer distance, so radical 3 over 2. And then pi is going to be negative 1. And all of those on the quadrant 2 should be negative. So I'm going to translate them down, put them in the inverse table. Again, I'm going to change my radical 3 over 2 to a decimal. It's roughly 0.9. We know that's 0.7, 0, negative 0.5, negative 0.9, and negative 1. So when I put this on a graph, x-axis needs to go from negative 1 to 1, so set it up the same way. I'm going to count by 12ths again on my y-axis, which means there's pi over 6, pi over 4, pi over 3, pi over 2, 2 pi over 3, 3 pi over 4, and 5 pi over 6, with pi up here. So now to graph this, I've got to be at 1, 0, 0.9 pi over 6, 0.7 pi over 4, 0 pi over 2, negative 0.5, 2 pi over 3, negative 0.9, 5 pi over 6, and negative 1 is at pi. So we've we've rotated the inverse chunk of cosine. Let's move on to tangent. Tangent graph. Let's see, what do I want to think about? The unit circle, negative pi over 2. Tangent is my x, or my y over my x. So that's going to be a negative 1 over 0. That's undefined. So that's going to translate down still as undefined. Okay, negative pi over 4. Now I've got radical 2 over 2, negative radical 2 over 2. So I'm going to have negative 1 there. Negative pi over 6. Now my opposite is negative 1/2. My adjacent's radical 3 over 2. I do my opposite over my adjacent. Multiply by the reciprocal. Gives me negative 1 over radical 3. At 0, that would be at my y over my x would be 0 over 1, so that's 0. Pi over 6, positive 1 over radical 3. Pi over 4 would be positive 1. And pi over 2, again, is going to be undefined. Translate these down. Negative 1 divided by radical 3 is negative 0.6. Now something to think about, when my y equals negative pi over 2, all my x values are undefined. So when I get down here, these are the same points we've had before. This is negative pi over 2, this would be pi over 4. I'm actually going to have a horizontal asymptote now. I've taken my tangent graph and I've essentially laid it on its side. So if I graph the other one, here's my other asymptote. Here's negative 1, positive 1. And then at negative 1, negative 1 would be negative pi over 4. Negative 0.6 would be negative pi over 6. 0, 0. 0.6 would be pi over 6. 1 would be pi over 4. And then that leads me to the asymptote. So if I squeeze it in here, this is what my squiggle now looks like.